Dear students, in today's class, we will discuss three properties: convolution theorem, initial value theorem, and final value theorem. So definitely there will be a question from initial value theorem or final value theorem or convolution theorem. That's what I am just making one more video based on these three topics, or we can say these three properties. Now we will see that convolution theorem, convolution theorem. What is the convolution definition? Y of n is equals to x of n convolution h of n. Y of n is equals to x of n convolution h of n, right? Now, first I will write it here. X of n z transform. X of n z transform is x of z. H of n z transform is h of z. Now, let me take y of n is equals to x of n convolution h of n. Z transform will be y of n will become y of z is equals to x of n convolution h of n. Convolution in time domain results in product in the frequency domain, x of z into h of z. That is the important of the transformation, right? Now, how to prove this? So again, we'll write the proof. Y of n z transform is y of z. Y of z is equals to summation n equal to minus infinity to infinity y of n z power minus n. What is y of n? X of n convolution h of n. N equal to minus infinity to infinity x of n convolution h of n whole into z power minus n. Now, according to the definition of convolution, what is x of n convolution h of n? X of n convolution h of n is equals to summation n equal to k is equals to summation k is equals to minus infinity to infinity x of k h of n minus k. So this is the expansion of the convolution, right? Expansion of the convolution. Now I'll use this expansion in this expression here, n equal to minus infinity to infinity. Again, x of n convolution h of n I will write here summation k is equals to minus infinity to infinity x of k h of n minus k whole power z power minus n. Now if you see that in order to prove the convolution theorem, here x of k is there, here n minus k is there, but here z term is only n is there. So what I will write it here, summation n is equals to minus infinity to infinity in bracket summation k is equals to minus infinity to infinity x of k h of n minus k whole into z power minus n minus k, okay, plus k minus k I will write plus k minus k. I'm just considering plus k and minus k. Now here summation k is equals to minus infinity to infinity x of k. Here z power minus n plus k minus k is there. Now I will take it as z power minus k here. Z power minus k. Remaining what we will be here, that I will write separately. Summation n is equals to minus infinity to infinity. I'm just separating this summation because here k is variable. Whatever variable the k is there, I'm just separating here. X of k, z power minus k. Similarly, n is a variable here. N equal to minus infinity to infinity h of n minus k into z power minus n plus k, right? Minus n plus k. I can write minus, if you take common, I will get n minus of n minus k. Minus of n minus k. Now, let n minus k is equals to n minus k is equals to some m you consider. N minus k is equals to m. Right? Now, don't write here, only we need to substitute in this one only. So then summation k is equals to minus infinity to infinity x of k z power minus k summation m is equals to minus infinity to infinity h of m z power minus m. So what is this expansion? X of z. What is this expansion? H of z. So this is the convolution property. This is the convolution property. Here, what are the key points we need to understand? Here, we need to write what is the convolution between x of n and h of n. That is summation k equal to minus infinity to infinity x of k h of n minus k. This is one important point. And here, we need to add plus k and minus k because we need to separate the terms so that we can write this x of z into h of z separately, right? Now we will solve few numericals based on the convolution. So the first one is, I'll write it as x of n is equals to u of n convolution u of n minus 1. U of n convolution u of n minus 1. So now you can write it here. U of n z transform. U of n z transform is z by z minus 1. What is the ROC? Mod z greater than 1. Now, what is u of n minus 1? If there is a shift in the signal, how much will get? Z power minus 1 into z by z minus 1. Right? So again, ROC is mod z is greater than 1. Now, this is the u of n and u of n minus 1. You multiply these, here x of n is equals to u of n convolution u of n minus 1. Z transform will be, what is the Z transform? X of z is equals to convolution in time domain results in product in frequency domain. That is z by z minus 1 into z inverse into z. Z inverse into z. This will both will get cancelled, right? Z minus 1. So now how much you will get x of z? X of z is equals to z by z minus 1 whole square. So somewhere we saw this type of form where we saw that n into u of n both are same, z by z minus 1 whole square only. So now what is the ROC? Mod z is greater than 1. This is the resultant ROC. Now we will see one more numerical. X of n is equals to n into minus 1 by 4 whole power n u of n convolution 1 by 6 whole power minus n u of minus n. Now, after seeing this question, one thing we need to understand, u of n is there. So there is a standard form a power n u of n z transform. Here minus n is there. So it is they given very simply they given, that is minus n here also minus n given. So no need to change anything over there. So whenever you saw this minus, so you remember that we need to apply the time reversal property because minus n is there. Now first I will write a power n u of n z transform is z by z minus a. Mod z is greater than a. Now minus 1 by 4 whole power n into u of n. What is the z transform? Z by, what is the a value? Minus 1 by 4. So z plus 1 by 4. What is the ROC? Mod z greater than 1 by 4. Mod z greater than 1 by 4. Here you need to write minus, again mod z is greater than, modulus of minus 1 by 4 is nothing but plus 1 by 4 because radius value to be positive. Now here one more term is that is n into, remember this product of n in time domain results in differentiation in frequency domain. N into minus 1 by 4 whole power n u of n z transform is minus z into d by dz of z by z plus 1 by 4. So now if you multiply the n in the time domain results in z in the frequency minus z into differentiation of the above signal, that is z by z plus 1 by 4. Now, so now what we will get here, this will become z transform will be minus z into, so if you differentiate this, what we will get, z plus 1 by 4 into z differentiation is 1 minus z into z plus 1 by 4 differentiation is 1 divided by z plus 1 by 4 whole square. So now this is n into minus 1 by 4 whole power n u of n. So n into minus 1 by 4 whole power n u of n, z transform will be minus z into 1 by 4 divided by z plus 1 by 4 whole square. This is the first term, z transform. Coming to the second term. What is the second term? 1 by 6 whole power minus n u of minus n. So whenever you saw that u of minus n, so you try to understand or try to recall that time reversal property. What is time reversal property? N in the time, n will become minus n, z will become z inverse. So now I will write here a power n u of n, z transform is z by z minus a, where mod z is greater than a. Now 1 by 6 whole power n, you take first n only, then we will modify it to minus n. 1 by 6 whole power n u of n, z transform is z by z minus 1 by 6, mod z is greater than 1 by 6. Now 1 by 6 whole power minus n by using time reversal property. Now we are using the time reversal property. 1 by 6 whole power minus n into u of minus n, z transform will be, you remember here, if n you are writing minus n, z will be z power minus 1. That you need to carefully you need to write. So 1 by 6 whole power minus n u of minus n, this will become z inverse divided by z inverse minus 1 by 6. What is the ROC? Z inverse greater than 1 by 6. Now 1 by 6 whole power minus n u of minus n, z transform is, z inverse is nothing but 1 by z. So we will get it here 1 by z divided by 1 by z minus 1 by 6. So now z only you take common and it will become, okay, here it will be 1 by z greater than 1 by 6. 1 by z greater than 1 by 6. Now z you send that side, 6 this send this side, that I will write here 1 by 6 whole power minus n u of minus n, z transform is here 1 divided by 1 minus 1 by 6 into z. Now this will become z you send that side, 6 you take this side, 6 is greater than mod z. Then what is ROC? Mod z is less than 6. This is the ROC for this signal, right? Now you see this is one z transform, this is one z transform. Now convolution in time domain results in product in frequency domain. So now what is the question given? X of n is equals to n into minus 1 by 4 whole power n u of n convolution 1 by 6 whole power minus n into u of minus n. So this is, what is the x of z will become, x of z is convolution in time domain results in multiplication in frequency domain, minus z into 1 by 4 minus z into 1 by 4 divided by z plus 1 by 4 whole square into 1 by 1 minus 1 by 6 into z into 1 divided by 1 minus 1 by 6 into z. What? Okay, now I will write that exact form. So minus z by 4 divided by z plus 1 by 4 whole square into 1 minus 1 by 6 into z. If you multiply and if you simplify, yeah, we can simplify that. Otherwise, you can leave up to here. So now, if we simplify this, what we will get? Minus z by 4, z by 4 divided by z plus 1 by 4 whole square. Here, numerator, if you take LCM here, 6 minus z by 6. Here also you can take 4z my 4z plus 1 also you can take, otherwise you can leave it like this, no problem. So minus z into, this will go to the numerator, 6 by 4. What is 6 by 4? That is 1 by 1.5. 1.5 divided by z plus 1 by 4 whole square into 6 minus z. Okay, so now here we need to write what is the ROC. What is the ROC? What is ROC? First ROC is mod z greater than 1 by 4. Mod z is greater than 1 by 4. Mod z greater than 1 by 4 intersection. What is the second ROC? Mod z is less than 6. Mod z is less than 6. That means where the ROC will lies in between 1 by 4 less than mod z less than 6. In between these two circles it will exist. Let me draw here. So this is the z equal to 1 by 4 circle and z equal to 6 radius circle. This is the 6 radius. So mod z is equals to 6. This is mod z is equals to 1 by 4. Where the ROC will exist in between these two, in between. Here is the ROC will exist in between these two. It's like a ring shape. That is what. Because if you see that one is right sided, another one is left sided. You can see that. That is why. So this is the ROC for the given signal. Now, next one. Next one is initial value theorem. Initial value theorem. What is initial value theorem? We need to find what is the initial value. We need to find x of 0. We need to find x of 0. So now, before finding this, we need to see that whatever the question, if they given, we need to understand what are the condition the x of z to be satisfied to find the initial value. So now, condition number 1. Condition number 1. Initial to apply the initial value theorem, there will be a, let us take x of z is equals to numerator and as well as denominator will be there. I mean numerator by denominator. Always order of denominator should be greater than or equal to order of numerator order. So this is very important. If you got order of the denominator is greater than the order of the numerator, then only we can use this initial value theorem. Otherwise, we cannot use that. And x of n z transform. X of n z transform is x of z. So now, what is x of 0? I need to find what is x of 0. X of 0 is nothing but summation z tending to infinity. I mean, not summation, limit z tending to infinity x of z. In the x of z, if you substitute z tending to infinity, you will get x of 0. That is the initial value theorem. Now, how to prove this? How to prove this? X of n z transform is x of z. What is x of z? X of z is nothing but summation n is equals to minus infinity to infinity x of n z power minus n. And one more thing, if you want to apply this initial value theorem, it should be causal. X of n should be causal. What is meant by causal? Only right-sided part. Only right-sided signals. No left-sided. That means your limit will become summation n equal to 0 to infinity, because it is a x of n is causal. That means it exists only in the right-sided. So that's why your limit will be n equal to 0 to infinity x of n into z power minus n. Now you substitute each value n equal to 0. X of 0 into z power 0 is 1 plus x of 1 into, I need to write here, 1 second, limit 1 second, is equals to, okay, x of 0 plus x of 1 z power minus 1 plus x of 2 z power minus 2 plus and so on. It will go on till infinity. Now, if you take the z limit, z tends to infinity both sides. Z tends to infinity if you take both sides. Both sides, if you consider, if you take, what we will get? Limit z tending to infinity x of z is equals to limit z tending to infinity x of 0 plus x of 1 into z power minus 1 plus x of 2 into z power minus 2 plus and so on. Now you see that z tending to infinity means, what is meant by 1 by z? Z inverse is nothing but z tending to infinity. What is 1 by z will become 1 by z is, z inverse is nothing but 1 by z. Z inverse is nothing but 1 by z. What is 1 by z will become 1 by infinity. That will become 0. Right. So now, what is limit z tending to infinity x of z is equals to, what is this value? Z power minus 1 0, z power minus 2 0, up to z power up to, so on, whatever the z terms are there, everything will be 0. Only you will get x of 0. So this is the formula used to find the initial value for the given signal. You will need to be very careful. It will be very easy problems also. So definite question this is. So if I want to find initial value, you remember one thing. If you are finding the initial value, that means x of 0 you are finding. X of 0 you are finding. You need to be understand that initial value means x of 0 you are finding. For that, you need to do that z tends to infinity in the x of z. Now we will see that two numericals to find how to find the how to apply the initial value theorem, and as well as, okay, first we will see that initial value theorem. Okay, first we will see that final value theorem also, then we will cumulatively we will see that, because in the question they will ask that find the initial value and final value for the following signals, like that they will give. So that's why, so I will write that final value theorem also. Combinedly I will discuss the question here. Now the final value theorem. Here we need to remember one point. Before applying this final value theorem, again, x of n is causal. What is meant by causal? Only it exists right-sided signal. And poles, whatever the poles of x of z should not lie on the outside of the unit circle. If these two conditions are not satisfied, if any pole lies on the unit circle or on the circle, so we cannot apply this final value theorem. So now final value theorem means we need to find x of infinity, we need to find. For this, here unit circle will play a major role. What is the unit circle radius? 1. So that is what here, limit z tending to 1, z minus 1. Limit z tending to 1, z minus 1 into x of z. Limit z tending to 1, z minus 1 into x of z. This is very important notation. So or you can write it as x of infinity is equals to limit z tending to 1, 1 minus z inverse. If they given in terms of z inverse, this is also possible. That's why 1 minus z inverse into x of z. So now all the poles should lies inside the unit circle. If any pole lies on the outside circle, this final value theorem we cannot apply. Right. So now we will see that one numerical based on the initial value and final value theorem. So before that we need to prove this one, right? So now I will write the proof. Now consider two signals x of n plus 1 minus x of n. What is the Z transform summation? N equal to minus infinity to infinity x of n plus 1 in minus x of n whole into z power minus n. This is the expansion, right? Z transform. Now, already I told x of n, it is a causal signal, or we can say right-sided signal. So then what is the limits? Limits will become n equal to 0 to infinity. One thing you remember, whenever you are applying the initial value theorem or final value theorem, x of n should be causal. That means it should be right-sided signal. So n equal to 0 to infinity. So you will get x of n plus 1 minus x of n whole into z power minus n. Now, if I apply z transform this side also, okay, let me first I will complete here. Now, n equal to 0, you substitute x of 1 minus x of 0 plus n equal to 1, you substitute x of 2 minus x of 1, n equal to x of 3 minus x of 2, n equal to 2, you are substituting, plus and so on up to, so last term, let me write it here, k value you substitute, n equal to, one second here, what I will write it here, instead of taking n equal to 0 to infinity, I will write it here, limit k tending to infinity, n equal to 0 to k I will take. So for our understanding, I'm writing here. So now again, so this one here also, I will write this one as limit k tending to infinity. So now n is varying from 0 to k, right? So what is the last value? K you substitute x of k plus 1 minus x of k. What is the before value? X of k minus 1, x of k minus 1 minus x of k. Sorry, x of k minus x of k minus 1. X of k minus x of k minus 1. Now, if you see that x of 1, x of minus x of 1, x of 2 minus x of 2, x of k minus x of k, x of k minus 1. Before that, x of k minus 1, it will be there. So now all will get cancelled. Only what is the leftover terms? Limit k tending to infinity. What is the leftover term? X of k plus 1 minus x of 0. What is this x of k plus 1? K value is tending to infinity. That means x of infinity minus x of 0. X of infinity minus x of 0. Now, what is x of n? X of n plus 1 minus x of n. What is the jet transform? Directly we know that x of n plus 1. What is the jet transform? Z into x of z minus x of 0 minus x of n. Jet transform is x of z. Right. So now, so this is LH side, this is RHS side, right? So z into x of z minus x of 0 minus x of z is equals to x of infinity minus x of 0. X of infinity minus x of 0. So now you can take x of 0, you can cancel it. Z minus 1 into x of z is equals to x of infinity. Right. Now, if you consider if I want to find x of infinity, z minus 1 into x of z, what is the z value? Limit. Okay, this side I need to write, right? Limit z tending to 1. So this is the derivation for final value theorem. You remember one thing, final value means you are finding the infinity, x of infinity. That means limit z tends to 1, z minus 1 into x of z. This is the final value theorem. Now, important numericals we will solve now here. Find the initial value and final value for the following signals. For the following functions, I will write it here. Find the initial value and final value for the following functions. First one, x of z is equals to z divided by 4z square minus 5z minus 1. ROC is mod z is greater than 1. Mod z is greater than 1. First we will solve this one. X of z is z by 4z square minus 5z minus 1. So now you remember that we need to find the initial value. If you want to find that initial value, we need to apply that initial value theorem. What is the initial value theorem? X of 0 is equals to limit z tending to infinity x of z. Limit z tends to infinity x of z. So now limit z tending to infinity. What is x of z? Z divided by 4z square minus 5z minus 1. Now, if you substitute z equal to infinity, what we will get? This will become infinity by infinity, right? So, you need to be very careful. Limit z tending to infinity, z divided by whatever the highest z term you take outside, z square into 4 minus 5 into z inverse minus 1. Now, so here one z will get cancelled. Limit z tending to infinity 1 by z into 4 minus 5 by z minus 1 by z square. Z square here it is 1 by z square. This is 5 by z, you write it. 5 by z minus 5 by z. Now, you see that now 1 by z, 1 by infinity, this will become 0. There is no other alternative. So what is the initial value? Initial value will be 0. X of 0 is 0. Now we will see the final value. You can write it here. X of 0 is 0. X of 0 is 0. This is the initial value. Now what is the final value? Final value is x of infinity is equals to limit z tending to 1, z minus 1 into x of z. Z minus 1 into x of z. Now, limit z tending to infinity, z minus 1 into what is x of z? Z divided by 4z square minus 5z minus 1. Now, this anyway, this z minus 1 term you need to eliminate. Otherwise, z tending to this will become 0. Final value also will become 0. In any way, you need to eliminate this z minus 1. So, whenever you are doing this final value, whenever you are applying the final value, generally what I will suggest you, factorize this limit z tending to 1, z minus 1 into z divided by 4z square minus 5z minus 1. What is the factorization? We need to do the factorization for this. So now how much we will get? Minus 4, and if you add this one, you will get minus 5. So 4 into 4z square minus 5z minus 1, right? So now I'll do one thing. I'll just take 4 as common here. 4 if I take common, z square minus 5 by 4 into z minus 1 by 4. Now limit z tending to 1, z minus 1 into z divided by 4 into, so z square minus 5 by 4 into z minus 1 by 4. So now if you try to factorize this, so minus 1 by 4 I want, so I will consider as minus 1 minus 1 by 4, minus 1 into minus 1 by 4. One into minus 1 minus 1 by 4, how much? Minus 5 by 4. So, but this is so in the question, just this is plus 1, plus 1. This is also plus 1. Here also plus 1. So this is plus 1. So now here only you can write then. Here only you can write it there. Z divided by 4z square minus 5z plus 1. Can write it as 4 is there. Minus 4 into minus 1. Minus 4 into minus 1 we will get minus 5, right? So I will write it as x minus 1 into x minus 4. Okay, not x, z. Z minus 1 into z minus 4, right? Now z minus 1, z minus 1 will get cancelled. So what is that we will get? So limit z tending to 1, z by z minus 4, z by z minus 4. Now if you apply that z equal to 1, what we will get? So 1 divided by 1 minus 4, that is minus 1 by 3. This is minus 1 by 3, right? It is minus 1. Okay, x of infinity is minus 1 by 3. Next one. Next one we will see now. Find the initial value and final value for the given problem. Now, find initial value and final value of x of z is equals to 0.5 z square divided by 1 minus 1.8 z power minus 1 plus 0.8 into z power minus 2. 1.8 z inverse plus 1 by 0.8 z power minus 2. Directly they given this. Here it is 0.5 divided by that sum. So this is the question. Now what is the initial value theorem? Initial value theorem. By using that initial value theorem, I need to find x of 0. X of 0 limit z tending to infinity into x of z. Now limit z tending to infinity. What is x of z? 0.5 divided by 1 minus 1.8 z inverse plus 0.8 z power minus 2. Now z equal to my infinity means what is z inverse will become? Z inverse is nothing but 1 by z. So z is infinity means 1 by z will become 0. So you will get 0.5 is the initial value. Now we will see that final value. What is the final value? By using the final value theorem, we can find the final value, right? How to find the final value? X of infinity is equals to limit z tending to 1, 1 minus z. Okay, we can write z minus 1 into x of z, or limit z tending to 1, 1 minus z inverse into x of z. You can write any one form, but here anyway z inverse they given. That's what I'm writing, 1 minus z inverse into x of z. So now what is this x of infinity will become limit z tending to 1. Which one we will use? Here they given z inverse, right? So either we can write 1 by z. You need to send this one numerator. We can do like that, or we can use this z inverse. So anyway, this is examination. We will use that conventional basic one formula we will follow. You can use either z inverse directly, or you can use this one. So now what is x of infinity will become limit z tending to 1, z minus 1 into what is x of z? 0.5 divided by 1 minus 1.8 into z inverse plus 0.8 into z power minus 2. Right. So now you just take this z power minus 2. That means z in limit z tending to 1, z minus 1 into 0.5 divided by 1 minus 1.8 by z plus 0.8 by z square. You take the LCM, what we will get? Limit z tending to 1, limit z tending to 1, z minus 1 into 0.5 z square, 0.5 z square divided by, this will become z square minus 1.8 into z plus 0.8. right? So this is what we will get. Now, if I factorize this, if I factorize this, limit z tendings to 1, z minus 1 into 0.5 z square divided by, I'll just factorize this one as z minus 1 into z minus 0.8, z minus 1 into z minus 0.8. Now, z minus 1 will get cancelled. What is the remaining term? I will write here, limit x of infinity is equals to limit z tendings to 1, 0.5 z square divided by z minus 0.8, z minus 0.8. Now, z value substitute 1, 0.5 divided by 1 minus 0. Is nothing but 0.2. You will get 5 by 2. So, what is 5 by 2 answer? 5 by 2 how much? 2.5. Otherwise, 5 by 2 you can keep like that. Now, similar way, we need to apply the initial value theorem and as well as final value theorem. For if they given any question, we need to answer like this. Right. So now we will solve one more numerical based on this initial value and final value theorem. Here. Next, what is the initial value we got? X of 0 is 0.5. X of infinity is 2.5. This is the answer. Initial value and final value. Now we will solve one more numerical. X of z is, find the initial value and final value. Find the initial value and final value. The question may be looking difficult, but it is very easy. Final values of the following functions. Following function. Let me take one more this one. X of z is equals to 10 into z into z minus 0.4 divided by z minus 0.5 into z minus 0.3. Now, what is the initial value? Initial value. That means we need to find x of 0. What is x of 0? Limit z tendings to infinity x of z. So limit z tendings to infinity. What is x of z? 10 into z minus 0.4 divided by z minus 0.5 into z minus 0.3. Here you need to be careful. Now here if you substitute z is equals to infinity, everything infinity by infinity, right? So that's why we need to take first z, we need to take common. That is the simple step we need to follow whenever we are finding the initial value theorem. So now 10 into z you take common, 1 minus 0.4 by z into z divided by, this is also z, this is also z. Z you take common, 1 minus 0.5 by z. 1 again here also you take z common, 1 minus 0.3 by z. Now z will cancel. What is the value we'll get? X of 0 is equals to limit z tendings to infinity 10 into 1 minus 0.4 by z whole divided by 1 minus 0.5 by z into 1 minus 0.3 by z. Once you write this, you apply the limit. Z is infinity means what is 1 by z? 0. So 10 into 1 minus 0 divided by 1 minus 0 into 1 minus 0. 1 minus 0 into 1 minus 0, 1 only, right? So we will get 10. What is the initial value we will get? Initial value we will get as 10. Now what is the final value? What is the final value we need to write? So now to find the final value, we need to apply the final value theorem, right? So what is final value theorem? X of infinity is equals to limit z tending to 1, z minus 1 into x of z. Limit z tending to 1, z minus 1 into what is x of z? X of z is nothing but 10 into z by z minus 0.4 whole divided by z minus 0.5 into z minus 0.3. So now if you see here, is there any cancellation is possible? No, cancellation is not possible. Cancellation is not possible. So that's why we need to, there is no other option. We don't have any other option because cancellation is not possible. If you substitute z equal to 1, what we will get? 1 minus 1, 0. Because if cancellation is possible, we can cancel it. If not possible means we can put x of infinity value will become 0. So this is the final value theorem. So now what is the initial value? X of 0 is 10. X of infinity is 0. Don't consider, sir, initial value 10 means final value should be more than that. Don't think like that. So you write whatever the value you will get. I think you understand, right? And one more very important problem. Very important problem. You can put that 4 star or 3 star. Very important for your VT examination. That is, find the inverse jet transform. Find the inverse jet transforms. Now, inverse jet transform finding, basically we can do in two ways. Basically the inverse jet transform we can find using partial fraction method and power series method, or we can say that long division method. Just we need to divide that long division method. Partial fraction method, inverse jet transform. Now this topic we will discuss in the next video, but this problem is very important. Whatever the problem I am discussing now, that is important. This is a special case in inverse jet transform. That's what I am discussing now, right? So now find the inverse jet transform of x of z is equals to log of x of z is equals to minus log of 1 minus A inverse Z. Remember one thing, this is a special case. Whenever they are asking you to find the inverse jet transform for logarithm only, this is the special case. Remaining problems, everything we need to use partial fraction method and power series method, but only for logarithms we need to follow this way. Now whatever the x of z they are given, first you differentiate this x of z, dx of z by dz. What is the differentiation of logarithm? Minus log of x, 1 by x, that is 1 by 1 minus A inverse into z, into what is 1 minus A inverse into z differentiation? Minus A inverse. So now what is your dx of z by dz is equals to A inverse divided by 1 minus A inverse into z. This is what, right? So what is A inverse? That is 1 by A. 1 by A minus 1 by z by A. So now you can write it as 1 by a divided by a minus z by a. So a will get cancelled. We can write it as 1 by a minus z. By a minus z. No. Now you multiply minus z here. Multiply. You follow only this procedure. Multiply minus z both sides. If you multiply the minus z both sides, what will get? Minus z into dx of z by dz. This is the step number 1, differentiate. Step number 1, differentiation. Step number 2, multiply minus z both sides. So minus z divided by a minus z. That I will write it as minus z into dx of z by dz is equals to this one. Minus z by a minus z is nothing but z by z minus a. Z by z minus a. Now, if we apply the inverse z transform, inverse z transform, minus z into dx of z by dz. What is the property? Multiplication of n in time domain, n into x of n is equals to, what is the signal? Z by z minus a. Now, you can see that, sir, it might be a power n u of n, z transform is z by z minus a. A power n u of minus n minus 1. Z transform is z by minus z by z minus a. So now, sir, both are same. No, whether I need to write, the two possibilities are there. A power n u of n, this is one possibility. Another possibility, a power n u of minus. My a power n u of minus n minus 1. These two possibilities are there. Now, which one I need to choose? You need to verify that what is the ROC given. Mod z less than a, mod z less than mod a. Whenever you saw the less than means it is a left sided, greater means right sided, less than means left sided. So which one we need to use here? This is mod z less than, greater than a, this is mod z less than a. Which one we need to use? Second one we need to use, because we need to select from the ROC, whatever the ROC they given. From that we need to write this carefully. So minus a power n into u of minus n minus 1. This is in the question, it will be there. Now I am writing in the question. Okay. So now this x of n, what is x of n will become minus a power n by n into u of minus n minus 1. So this is the inverse z transform only for logarithms given. This is a special case problem. If they given the inverse z transform, you follow the step number 1, up, do the differentiation. Step number 2, multiply minus z both sides. Now step number 3, apply inverse z transform. So this is very important problem. In the next class, we will discuss how to find the inverse Fourier transform by using partial fraction and power series method. That we will discuss in the next class. So you can watch this video by 2 times faster, I think, right? Yeah, you can do that. Thank you.